Hi guys, coming from UiPath Hacks here. Today's video is about another juicy and a bit futuristic sounding topic: computer vision and UiPath. No, it's not about the man spying on us through our webcams, but about an AI-powered method of identifying elements inside image-like environments and labeling them further. In UiPath, these elements are then attached selectors and we can interact with them further in our workflows. So how does computer vision actually work? Computer vision is an application of machine learning where neural networks are used to identify elements such as text inputs, checkboxes or buttons without the use of classical selectors. Computer vision activities, or short CV activities, are created mainly for automation in virtual environments like VMWare, remote desktop connection or Citrix. They also perform better than traditional selectors on PDFs or technologies like Flash or Silverlight. These activities can bypass inexistent or maybe unreliable selectors by providing the neural network's images of the window. And these images are sent to a server that analyzes them and sends back the identified and labeled UI elements. Anchors are used to pinpoint the exact location of the UI element you are interacting with. Also, it has to be mentioned that to get CV to work, you need to have an API key that you can get from the cloud UiPath.com portal, and you have to specify the URL. There's a default one, which is cv.uipath.com. Next, we will compare the classical selector-based activities with computer vision selectors. CV activities allow you to interact with elements inside virtual machines or parts of web browsers where a set of elements is seen as a picture and not as individual elements. And in this case, of course, the traditional selectors fail. All CV activities need to be part of a CV screen scope activity. And if that screen changes, you need to use a new CV activity. This is basically like similar to the attach window activity. There is some error reporting as we work with CV elements. It is used to basically provide feedback to UiPath when CV fails. If we fail to select an element, or if the anchor is not correct, we will see a red error message later on, and we will have the option to submit this to UiPath for further investigations and improving the machine learning model in future versions. So why, you might ask, would we then ever use the classical selectors again? Speed. The answer is speed. CV activities need clearly more time to run, with sending the pictures to the server and waiting for the feedback. But in a scenario where the classical selector does not work at all, I would happily trade a few seconds of runtime for a running solution like computer vision. So this concludes the theory part. Let's have a look now and try to test out some key computer vision activities. We have quite a list of activities, but we will focus on 4 of them. I would like to test out the computer vision click activity, the element exists, the get text, and the type into. And to run any of these, we need to use also the CV screen scope. This is basically a wrapper or container for the other computer vision activities. and it also acts as a refresh mechanism. And this is basically to indicate the area that we would like to focus on for our automation. It's kind of like an attach window in a way. So I have here a CV screen scope activity. We have the default Microsoft OCR engine for image OCR. And then let's try to use the first activity, CV get text. If we try to select so let's try to have a look into a PDF. I have this PDF on computer vision, and we will attempt to get some text here, let's say the title. If I try to indicate the PDF first, for the first time, I will get this error message: the server API key missing or invalid. Please copy it from the licenses page. So I have to go to my cloud UiPath.com page. I'll close the error message. I have to go to licenses, then to other services, and we have here the computer vision tab. I have not yet generated an API key, so I have to generate a new key. Yes, I'm sure. And here it is. I can now copy my API key, go back to my CV screen scope, and paste the API key here. All right. For the URL, let's have a look to see what is the default one we can use. Let's have a look on the UiPath docs page, CV screen scope. You can scroll down and we should find here the URL. So it is of course the URL of the server that runs the computer vision service. And by default, this property is set to CV UiPath.com. So let's put this here as well. And we still have an error. All right, let's see now if we can indicate on screen and have the CV screen scope work. So I want to automate in this PDF page. I will click here. So it is now detecting the screen and no more errors for now. So let's try using now the CV get text activity. I will indicate on scope, and let's say we want to take or get a text of the title. And you will see that you have here an additional box which can show you all the elements that are available or identified by the computer vision algorithm. And we first have to indicate the target. So this works as a combination of target and anchor. The blue box is the target, the one that we need to get the text from, and the green one is the anchor. And UiPath automatically selects the best anchor to make sure that we get the desired target. So if I want to take the full text, the full title text, I could click here, and the anchor will be the description above. And as you hover the mouse over, you see different proposed target and anchor combinations. Yeah, but if we want to take the whole text, I would just click here, and this is it. I have now the anchor and the text. So let's try to run this. I'm basically trying to compare the classical get text activity and the CV one. For the classical get text activity, if I want to indicate on screen, you see that I can't get to the underlying elements of this page. So in this case, if I wanted to get the title, I probably would get something else. And this is a good example. PDFs are a good example where computer vision selectors work much better than the classical ones. So I'm getting the title text with the classical get text activity, and then I'm logging it, and then I'm trying the computer vision get text activity, and I'm logging that. So let's see if this works. Let's have a look at the output. So the text captured by the classical get text activity is something which does not make too much sense, AV page view, and the text captured by the CV get text activity is foundations of computer vision. So it's correct. It has correctly identified the area in which I wanted to get text from, and it has done the OCR correctly. So that worked quite fine. Now let's have a look at the click activities, the classical one and the computer vision one. We will use the same PDF, and we will attempt to click on this See Profile button. So let's see first the classical click. It can't really sense the button. It can't see the element. So let's see if that will work. I will comment this section above. So let's have a look. Let's try to run this. Yeah, we even have an error. Oh, sorry. That's from my computer vision activity. I'll comment it out for now. Let's try the classical click, see if that works. Yeah, it has clicked. We've seen somewhere here in the middle of the screen, so it was not able to see the button and get at least the coordinates. So this does not work. I will comment it out, and now let's try to do the click with the computer vision activity. We have already the screen scope activity here, and inside it we will have a CV click. So here it is. It has identified anchor and the target by itself. Let's run this. And it does click on the button and opens this ResearchGate page. So it has worked quite nice. Yeah, so again we see how using computer vision activities we can get to the underlying elements inside PDFs, for example, or inside connections over virtual machines, remote desktop connection, or Citrix, for example. Now let's have a look at the element exists activity, and let's compare the classical element exists with the computer vision one. And again, we will use the same PDF as for test. Let's check if we have this button visible or not, the See Profile button. So I will indicate on screen with the classical element exists. Of course, I can't reach it in this PDF. So most probably this will not work. Let's create here the variable. For that, and we will log it. Make a string out of the result. And then let's use the computer vision activity. And with this one, we can drill down to the actual button. Yeah, and then let's log a message here. We have the result here. Let's create a variable bool CV element exists. It will create it in the CV screen scope. So we have to change the scope for that. It is in the do. All right, now we can reach it from outside this screen scope activity, and we can show it here. So this is our sequence. We first run the classical element exists, we see what is the result, and then we run the computer vision one and we check the result. We have an error here. I forgot to put here the string because I have a boolean. And let's run this. Let's see what's happening. So they are both true. Let's make sure that we set them as false in the beginning, and they will only become true if they're really found. All right, they are both set to false. Let's run again. And the output is true for both. So somehow the classical element exist activity was still able to find the button inside the whole PDF, even though we were not able to actually drill down to it. So I'm not sure if this is an artifact or if it was really able to find it. Let's check here. Element exists and CV. Yeah, so this one has worked surprisingly. I'm not quite sure why, but it did work. And now let's have a look at the last activity, or comparing the last two activities, the classical type into activity and the computer vision type into activity. And for that, I've chosen a new PDF that has some editable input fields. So let's see how the classical type into activity fares in this editable PDF. Let's indicate on screen. I'm trying to type in the text in a given name. We see I can't really select this field. I'm trying to type here the text classical type into, and then for the computer vision one, I try to type a text inside the family name text box field, so it has identified the anchor and the target, and I will try to type in the text CV type into string. So let's see how that works. I'll run this. And we see we have an entry for the second text for the computer vision text, but the first type into activity was not able to type its text because it could not identify this element with its selector. So this was the short overview of the 4 activities, classical ones and computer vision ones. We have seen basically first the get text activity, classical and computer vision inside the PDF. The classical activity failed. We have looked then at the element exists activity. We've looked, at the click activity, and the classical click activity failed as well. We've had a look afterwards at the element exists activity, and somehow the classical element exists activity worked, as well as the computer vision one. And then for the type into activity, the classical one again failed on the PDF. So in case you have to use this kind of activities inside PDFs, or maybe in virtual environments like VMware, remote desktop connection, or Citrix, or even on some older websites which are using Flash or Silverlight, computer vision activities with their selectors work quite well, as we have just seen. This was it for today's video. I hope you found this useful, and if you did, please hit the like button, and see you next time.
Hey guys, if you are new here, please hit the subscribe button and turn on the bell notifications so you won't miss out on future content. Thanks!